So in this example, we're given a z-value of 0.28, and we're asked to find the area under the curve that corresponds to that. So first things first, I'm going to go ahead and throw up a little picture of the normal distribution. That's the best you're getting. And so if I go ahead and put the mean right here at 0, then I can tick mark this going 1 in each direction by the standard deviations. Okay, so the z-value we're given is 0.28, so that's pretty tiny. Go ahead and that would be about here. So the thing to keep in mind is that when you look up these z-values in the chart, it's all the area to the left of that z-value. And so if I go ahead and connect this up, we're looking for this amount of area. The other thing is if you keep in mind that the entire area underneath this curve is 100% if you did everything, well, you can see that right here, this would be 50% if I cut it right at z equals 0. So since this is a little bit bigger, we should expect to get something a little bit more than 50%. So if I look up z equals 0.28 in my table, I first look for 0.2 in the rows. And so I look and I find that. Got it? And then you look in the column, and in this case, the column is 8. So I've got 0.2, and I'm looking at 8. And so I'm getting 0.6103. So my area under the curve, or my alpha, when z is equal to 0.28, is coming out to be 0.6103. Now, they're probably going to be asking you for a percentage a lot of the time, and so you'll be expected to convert that. So just move this over 2 hops to the right, and you get 61.03%. And so there we go. If they give you a z-value of 0.28, you look at the row is the first 2 digits, including the decimal, and then your column is the 3rd digit. Pull that up, and remember that that's going to be the area to the left of that z-value. And that is this example.